Hello everyone, I hope you are doing well. This is Hybrid Plus channel, and in this video I want to talk about the AC motor. It has two types. One of them is the asynchronous and the second was the synchronizer. At the next slide you will see in which vehicles are using this type of the motor and what's the different component of it and what's the duty and how it's operates. So let's see the definition of it. It's an electric motor consists of two main components. It's a stator is a stationary component, whereas the rotor is a revolving component. The other component that we have is the main case, main shaft, pump gear, and pulleys. Also, it has a fan to reduce the heat. It has a protect cover at the back side, and it has a fin on the main body. These fins on the side of the casing helps to increase the contact surface, and the main shaft supported by bearing. Stator, it's the material of that is a steel cylinder with slots and copper coils woven into a precise shape. The power electronics transform the DC electricity from the battery into three-phase of AC current to feed these coils. And synchronous speed refers to the pace at which the magnetic field in the stator rotates due to the current flowing through it. Inside the housing, there is a stator. It's stationary and does not rotate, and it consists a number of copper wire which are wrapped into the coils. It's three-phase, as I said, induction motor, but those are separated set of coils in the stator, and the end of each set are attached to the terminal. The end of each set are attached to the terminal. The rotor connected to the shaft, to the main shaft actually. And this another name of the rotor we can say as a squirrel cage. And it's the photo and the shape, actually the open photo of the AC motor that you can find it in the different vehicles. As you can see at this slide, you can see the operation of the which vehicle has a IC engine or AC motors. Like the components for the IC is a fuel tank, IC engine, then we have fuel filter neck, and type 2 for the charging socket actually is related to the electric motors. Then we have battery, onboard charging, we have combustion engine, and electric motor transmission. AC voltage is put to the copper coils, and as a result we get a rotating magnetic field. That field induces volts in the rotor, which in turn causes current to flow. That flow of current produces its own rotating magnetic field in the motor, which lags behind the magnetic field of the stator. It's the definition of the AC voltage into that machine, and in this slide you saw the different components, the vehicles that has IC engine and the electric motor, or we can say as a traction motor, AC asynchronous type of the motor. And you can see the flow of fuel and the flow of electricity. Pros of it, it's a high effectiveness and ineffective to produce. Rare earth elements are not required and nearly flawless dependably. Cons is more strong cooling system required and low power density. The Audi, it has this type of the engine, and then Mercedes-Benz EQC, and the Tesla Model X35, it has this type of the motor. But Tesla another like it depends. Tesla same names, they are using DC motor also. Synchronized motor, it's a permanent magnet in the rotor of synchronous permanent magnet motors, hence the name of the motor. Creator, a naturally occurring revolving magnetic field. These motors have locked and not slipping rotating magnetic field in the stator and rotor. You can see the different name of this type also. Like it has a stator, it has a rotor. Most of the main components are the same between the asynchronous and the synchronizer. According to definition, it has a slightly different between both of them. Then in here we have one of the main components that rises the motor's power density and efficiency is the permanent magnet in the rotor. In PHEVs, permanent magnet motors are the only type of motor utilized because of its higher power density, which translates to great power in small volume. These cars have a limited amount of room in the gearbox housing the electric motor, and in here you can see the open section of the AC motor for the synchronized, and you can see the components of the permanent magnet and the induction motor. Just the induction, it has a rotor windings. The permanent magnet also it has it, and most of the components are the same, just a structure is a little bit different. As you can see, both of them has a stator windings, has a rotor, and they have a stationary stator. The pros is much more high effective efficiency, lower cooling needs, and power density is high. For the cons, its products cost is high, material are rare, and theoretical danger of demagnetization it has. And actually, it's open structure of the Porsche Taycan, that you can see AC motor, and there is other component structure. Then you will see at the next slide the full structure of it, but in here it's open structure. It can be with the internal combustion engine also, but this one it was electric. It's a Porsche Taycan that we have it. It has a AC synchronizer motor. Then in here we have Jaguar. We have Jaguar actually, I-Pace is the full name, and we have Hyundai also. It has this, it's using the same motor, Hyundai Ioniq Q5. Thank you for watching my videos, and please, if you like the video, subscribe my channel and press the bell button. And if you want to see the operation of the DC motor, because DC motor also it has a two type, it has a brushed and brushless, and what's the difference? To know about them, you can check at the description link. There is a link and you can see the videos. Thank you to watch my videos.